My name is Thorstein Holt. I'm the president of Holtec Gas Systems, and I've been working in the gas separation industry starting at the Norwegian Institute of Technology in 1984. I travel a lot and visit customers all around the world who are considering to purchase nitrogen generators, and I see they have difficulties selecting the right system. We get it. There are a number of factors to consider when selecting the right size. We're therefore making this video to discuss the main 4 factors to help you get it right the first time around. The 2 types of nitrogen generators that we offer are membrane type and pressure swing adsorption PSA type. Both require a source of clean, compressed air, and in a future video we'll talk about the differences between these systems. There are 4 major factors to consider when selecting the right nitrogen generator: purity, flow, pressure, and temperature. And with me here today I have my longtime friend, business partner and Chief Technology Officer Ken Jones, which will introduce himself and address some of these factors.
Thank you, Thorstein. My name is Ken Jones. I graduated from the University of Wales in chemical engineering in 1966. I worked for 41 years in large corporations, and in 2007 I became a partner at Holtec. Incidentally, I transitioned from Europe to the USA in 1987 and have been working in gas separation processes since 1981. So let's start by discussing the purity of the nitrogen that is to be generated. Nitrogen is used in situations where air can't be used because of the oxygen content. Oxygen is a highly reactive gas, and many processes and operations won't tolerate air because of the 21% of oxygen contained. However, there are large variations in what is tolerable depending on the particular application. For example, if the nitrogen is to be used to prevent combustion, a purity of 95 to 97%, 3 to 5% of oxygen is sufficient. If the nitrogen will be used to heat treating metals, for example, the required purity could be up to 99.999%, which is 10 parts per million of residual oxygen. It is important to know the purity your process can tolerate because both the capital cost and the operating costs of a nitrogen generator rise steeply as the purity increases. Note here that nitrogen from bulk liquid always comes at high purity, and the gas purity you may be used to is likely to be higher than that you would actually need. Your generator supplier can advise on this matter.
And at Holtec we can help with industry references or a test plan to help you determine what purity you need. Next, we'll talk about flow. It sounds easy, but it can be tricky. Understanding how you use nitrogen is critical to getting it right. As you can see on these graphs, in the first you see steady flow, next with a start and stop pattern, and last rapidly changing with peaks and valleys. In all, the average flow is the same, but maybe not the required nitrogen system. Sometimes you need a bigger nitrogen generator, a bigger nitrogen receiver, or maybe we have another solution altogether.
Yes, we often come across the second and third patterns, but we're always happy to help to size the right system for you. Moving on to the issue of the required pressure. Clearly, the pressure needs to be high enough to meet the need. But the pressure at which the nitrogen is produced also impacts the capital cost and the operating cost of the generator. To give you some examples, for laser cutting, for example, maybe around 450 pounds per square inch is required. For corrosion protection of fire sprinkler piping, about 40 pounds. Food packaging often is 10 pounds per square inch or lower. You can operate at higher pressure, which results in a smaller nitrogen generator, but compressor costs and operating costs go up. Your supplier will be able to guide you to the optimum pressure for your particular application.
Many times you can use an existing compressed air system to reduce the overall capital cost. It's not a problem if the air is dirty because we can clean it up. Lastly, let's talk about temperature. And what temperature are we talking about? Well, it's the ambient temperature. As the temperature goes up, the capacity of a PSA system drops or the oxygen content in the product increases. This is often not well communicated in the gas industry, and performance tables are typically at 70 degrees Fahrenheit. However, this is usually not realistic, so we'll let you know what system you need for both cases, and you can choose based on your priorities. At high temperatures, a PSS system will be bigger and a membrane system smaller. What both systems have in common is that the air consumption goes up with higher temperatures.
Yes, this is a critical point. Without due diligence, a PSA system may not perform well in hot weather, as it was designed for, say, operating at 70 degrees Fahrenheit only. So that concludes our introduction, and the takeaway is that all four factors we discussed here must be considered in order to optimize your nitrogen generator and avoid potential future frustration.
So that's it. We hope you found value in this short tutorial. And of course, if you have any questions, please give us a call. We are here to help.